Hello guys, welcome to my YouTube channel. So in this chapter we're going to be talking about how to create a simple token. This token can be in charge of transfers, transfer from, have functions to check your balance, approve function, transfer from, just a basic token. So let's get started. So first of all you have to create a file. Yeah, you go to your remix, you get a file, you create a file, and you can name it anything. You can say I named my own token or so we're going to be naming our custom token. So let's get started. So first of all, we declare our SPDX license. So SPDX license. So SPDX license we declare it as MIT. So we declare our Pragma version, which is going to be 0.8.0. Pragma, so 0.8. Actually, this Pragma version can be anything. It can be 0.8.0, can be 0.8.9, can be 0.8.7. You just have to. Well, we're doing 0.8.0 to be on the safer side. We can also do greater than. Greater than. Sorry. The greater than, yeah, we can also do greater than 0.8.0. This simply means it should compile with this version. Anything greater than 0.8.0 is okay. So we can say 0.8.1 is okay, 0.8.2 as far as it's greater than 0.8.0. So let's just leave it as 0.8.0. So you have to actually put this Pragma version in order for this contract to be able to compile. You can see the list of compilation. You can see the list of versions that will be able to compile. Oh, so what did I do here? Oh, we just have to we have to leave it at 0.8.0 for it to be able to compile. So we're going to name our contract, which is going to be our contract name. We can name our contract anything. So contract token. So this contract token is going to house all our function, our variables, our whatever we're going to do in our contract. This contract is going to house it all. So you can name it token, you can name it my name, you can name it whatever, you can name it whatever, it will still compile. So name it token. Notice once your code is okay, once it automatically compiles. You can see it automatically compiles on to compile. So once your code is complete, once your code is correct, it will get this green check mark. Once you have an incorrect code, it will draw this error. And this can, if you hover on this question mark, it will give you a proper detail on your error. So first of all, first things first, we're going to do our string. We're going to name our contract public name. So it's going to be a string. So we can name this whatever. Can name it our token. Can name it my, let's just name it my token. Then string public symbol. So we can give you anything. We can MTK. So giving in this name of my token, I'm giving this symbol of MTK. So let's compile and see what we've done. Then we deploy. So let's see what we've done. Name, my token, symbol, MTK. Yay. So let's go back to our code and continue coding. So what next? What next? We're going to do our total supply. Yeah? Our decimal and our total supply. So we're going to do public, going to do int 8 public total, sorry, total supply equals to, now let's save this first. I think that's no, sorry. Unit 8 is supposed to carry a total decimal. So we're going to do decimal equals to whatever. I can even give it 10 decimal, give it 9, whatever. But most tokens come with 18 decimals. But I like to use 9 because it's kind of shortening my work. I hate putting all those plenty zeros. So we are decimal now. So for unit 256, we're going to do a public um total. Sorry, I have to put our underscore here so we don't get confused. Total supply equals to let's do a 1 million token. 1 2 3 1 2 3. Then we multiply it by 10 raised to power decimals. Yeah, you understand this line? So what this basically does is that our 1 million token, yeah, we are multiplying it by our decimal, 10 raised to power decimals. That means we are adding 9 zeros after our 1 million token. We're adding 9 zeros. Why we're adding 9 zeros is for us to be able to, it's for, whenever you're adding a token to your MetaMask, it often asks for a decimal. So that is why we're adding these decimals, whatever. So, and yeah, so that's all for that. I think that's all. We've done a string public, so let's check it out. What we've done so far. So ladies, deploy again. Yay, 9. Yay. You can see all the zeros have been added. You can see it's 1 2 3 4 5 6 7 8 9 and 1 2 3 4 5 6, which is our 1 million multiplied by 9 zeros. 9 zeros have been added to our 1 million. So yay, so we've done that. So what are we going to add next? I think our mapping. Yeah, our mapping. So let's not forget, yeah, mapping. So let's do our mapping. Going to be address to give us uint 256. Sorry, uint 256. So we're going to name this. We're going to give this a public. This will automatically give us a getter function. Public. We're going to name it what? Balance of. I'm going to name function. This is what this mapping basically does: is to taking an address and returns the units. So you're taking an address of any holder of the token, then return the balance of the token, balance of the owner of the token. Yeah. So what next? Our other mapping, which is going to be our address into another mapping, going to be an address returns units. Yeah. 26. So get the name is public and allowance. Yes. allowances. Yeah, right. So what this basically does is taking an address, it taking two address, this address one and address two, then returns a uint. Basically you're saying let let these two address share a number. Like we're assigning, let's say we are assigning 200 to these two address. Store 200 for these two address. This address one and address two will be having 200 stored in this variable. So declare our mapping. I think that's all for mapping. So yeah, one thing supposed to have declared this first. So we're doing our address is going to be public, then owner. We definitely want our contract to have a owner. I mean, yeah, because all the tokens will be minted to our owner's address. Yeah. So let's declare our events. Events, which is going to be transfer. Yep. So expand address indexed to from address indexed to then our unit 256 value. So what this event basically does, it registers this event. It registers what happened to the blockchain. It gives information of the address the transaction was from. It gives information of about the address the transaction was going to. It gives information about the amount that was transferred. This gives information about a transaction, this event. So let's do another event, which is going to be approval. Yeah. So approval here. So address spender event 256 value. Yeah. So I think we are done with our events. We're done with our events, our mapping, and our stable variables. I think that's all for all. So let's check out what we've done. So we deploy this, we check it out. You can see our allowances is a get automatically is a getter function. Balance of automatically is a getter function. So this takes in an address. So let's check for allowances. Yeah, address, another address, then call. You can see it's 0 now because we have not set any allowances for these two address. It's 0. This first one is first address and second address. These share this value is 0. Let's check balance of. Balance of taking one argument, which is an address, and returns a uint, which is 0. So for now, this doesn't have a balance.